Okay, so here's your circuit. So we start here in number 1, which is asking us to find f at -1. So we're looking for the y value when x is -1, and that comes from the point on our graph right here, right? The y value is always our closed dot rather than our open dot. So the answer is -1. Okay, so we look on our rest of our answers, and here we go. We found -1, so this one is going to be number 2. So this one says, what is the limit as x approaches 1? Well, how do we find the answer to any limit problem? When we try direct substitution, that's always what we want to try first. We get 1 cubed minus 1, which is 0. We get 1 plus 1 minus 2, which is 0. That tells us that we have to do some sort of algebraic manipulation. In this case, we're going to be factoring, right? We're going to factor the numerator and factor the denominator. So this is a special type of a cubic factorization with an a value that is x and a b value of 1. Okay? So this is a special cubic factorization. Factors to x minus 1. And then that remaining stuff is x squared plus 1x, which is just x, plus 1 squared, which is just 1. Okay, so that is our factorization. If we have an a minus b, then it factors to this a squared minus ab plus b squared. Right, that is our special cubic factorization for an a cubed minus b cubed problem. And then on the bottom, what numbers multiply to give us -2 and add to give +1? X plus 2 and x minus 1. Okay, so I can divide x minus 1 by x minus 1, and that gives us a 1. So now that I've done that, I can once again use direct substitution and plug my 1 in for all of my x's. 1 plus 1 plus 1 is 3 over 1 plus 2 is 3. So the limit of our function as x approaches +1 is 1. So that brings us over here. So this is now going to be our number 3. So we put a 3 here in this box because it's the third problem that we are doing. Okay, filling in the table above, what value would take the place of E? Okay, so we have an A, a B, a C, a blank, right? It's undefined at 2. If we plug in 2, we get 0 over 0. So this is where we have your discontinuity right there, undefined at 2. So in other words, I get my calculator and I plug 2.01 into my x. Okay, plug 2.1 into your x. So let's see, if you have a calculator, this should be nice and quick. So plugging this into our calculator, 2.01 minus 2 over 2.01 squared minus 4 came out to be 0.249377, which I believe there's an option for this one back on the front page. Okay, so this one is going to be number 4. So number 4 goes here. Oh, and this is one of our lovely algebraic manipulation problems. Right, our special word that we're supposed to know is the conjugate. Right, this is our algebraic manipulation because when you plug in 0, we get 0 over 0. So what is the conjugate of our numerator? Right, root x plus 3 plus root 3. And I multiply that on top and on bottom. Plus root 3. So when we do our distribution, the root x plus 3 times root x plus 3 is normal, regular, old-fashioned x plus 3. Okay, and then we would have a negative, and then we're going to have a positive of the same thing. So those guys cancel each other out. We don't even have to worry about writing them down. One is positive, one is negative. They give you a 0. But the third thing we have to do is multiply negative root 3 times positive root 3, which is minus 3. Okay, and then on the denominator, we have this ridiculous denominator here. But that's our denominator. Okay, we're still taking the limit as x goes to 0. So looking at the algebra, 3 minus 3 is 0. And then x divided by x is 1. Okay, so we're really looking at the limit as x approaches 0 of 1 over this ridiculous denominator, root x plus 3 plus root 3. Okay, which hopefully now, if we do direct substitution, we can take our 0 and put it in for x. And I get 1 over 0 plus 3, which is root 3, plus another root 3. So how many root 3's is that? 2 root 3's. So 1 over 2 root 3's is going to be your final answer for this limit problem. And let's see, is that an option somewhere on here? So this is not an answer choice, but there is the answer choice 0.289. So if you put it in your calculator, then you're going to get this decimal. I prefer to have, of course, the real answer rather than this decimal. So 0.289 is over here, and this is number 5. So we have a 3-part definition for continuity. Number 1, does f of 1 exist? Okay, that's our first question. Then actually, it is defined. F of 1 is defined. We have an equal sign right here. Okay, so f of 1 is defined, and f of 1 equals 1, right? Because anything less than or equal to 1, the x value is the same as the y value. So f at 1 is positive 1. Okay, so first of all, f is defined. Now, how about the limits, right? This is going to be our determining factor. Of course, the limit as x approaches 1 from the left, right, of our function is just 1. That's the y value that we're talking about here. Okay, so if we're looking at the left of negative 1, then you're looking at y equals x. Okay, so there's the limit from the left, right? This is the left side, y equals x, which means the right side is your other equation, 2 times 1 minus 3. Okay, so 2 times 1 minus 3 is 2. 2 minus 3 equals negative 1. So the left limit is positive 1. The right limit is negative 1. So does the limit exist? No. Okay, the limit at 1 does not exist because the left limit and the right limit don't equal each other.
So is it discontinuous?
So this function is in fact not continuous because the limit does not equal, or the limit does not exist. And in order for a function to be continuous, that's one of our 3 things. The limit must exist. Okay, so you plug 1 into your top equation, you plug 1 into your bottom equation, and you see what their 2 values are. And these ones are not the same, so our function is not continuous because the limit does not exist. Okay, for negative 4 is just below this. So here is this number 6. Find the limit as x approaches negative 1. So we're looking at the graph. From the left we approach 0. From the right we approach 0. So the graph is trying to go towards 0
Supposed to find the answer for?
as x goes to negative 1. Okay. Okay, this takes us over here to a many time missed problem, our fraction over x. So this is number 7. So we deal with our numerator first, right? We have a fraction minus a fraction. And in order for them to be able to be subtracted, we need to have the same denominator. So we're going to have a denominator of 2 plus x times 2, right? We combine both of our denominators, which means this 2 gets multiplied over here, and this 2 plus x gets multiplied over there. And we still have the sign of minus in between them, right? There's a subtraction symbol in between there. So this is how we can shortcut, right, our math hack for this fractional subtraction. We have two denominators that multiply together, so 2 plus x times 2. And then we multiply diagonally, so the 2 multiplies by the left numerator 1, the 2 plus x multiplies by the right numerator 1, and we still have subtraction. Okay, so this is where I see some problems with some mistakes. So 2 minus 2 is 0, but we still have to do minus x. So our top thing is a negative x, right, divided by 2 plus x times 2. And then rather than dividing all of that by x, I'm going to multiply it by its reciprocal. So not division by x, but multiplication by 1 over x. Okay, so these are our algebraic manipulation so that we no longer have 0 over 0 in our direct substitution. Okay, so a couple other things can happen. I can divide my x by x. X divided by x is negative 1, right? I have a negative and I have a 1 left. So I'm looking at the limit as x approaches 0 of negative 1 over 2 plus x times 2. Okay, and if you wanted to multiply that out there, distribute it, and get 4 plus 2x, that's fine also.
Wait, what did you do to the x's?
So we have negative 1 over 2 times 2, which is 4. So this has an answer of negative 1/4. Okay, that takes us over here to this one. And the question says basically, where do we have a vertical asymptote? Okay, so in order to figure out where our vertical asymptotes are, our first job is to factor all of your quadratics. Get everything into its factored form. Okay, everything into its factored form. So what numbers multiply to give me 6 and add to give negative 5? Right, so x minus 3 and x minus 2 are the factors that would multiply to give us that quadratic, right? Negative 3 times negative 2 is positive 6. Negative 3x, negative 2x added together is negative 5x. And then what numbers multiply to give us negative 15 and add to give positive 2? X plus 5 and x minus 3. So notice that some of these factors can divide each other, right? The x minus 3 divides the x minus 3. So from pre-calculus, we know that we would have a hole in our graph where x minus 3 equals 0. So in other words, we would have a hole at x equals 3. And also from pre-calculus, your vertical asymptote comes from your denominator that's left over, right? So we have to know what makes that 0. Whenever we have a 0 in the denominator, we're going to have a vertical asymptote, and that happens at negative 5. So this function f has a hole where x equals positive 3, and it has a vertical asymptote where x equals negative 5. And that's the question we were asked about, is where does it have a vertical asymptote? Okay, so negative 5 takes us over to here. This is answer number 9. And this question says, where is there a removable discontinuity? Which is talking about a whole. Okay, so our removable discontinuity is one where the limit exists. Right, the limit exists at a removable discontinuity, which is just a whole. The limit does not exist at a non-removable discontinuity, like a jump discontinuity. But it's all about limits. So if you want to prove something is a removable, then prove that the limit exists there. Okay? So once again, just like the other one, we're going to factor, and it's the exact same problem, right? This factor to x minus 3 and x minus 2. And then the bottom factor to x plus 5 and x minus 3. So like we set up above, the values that factor and cancel are going to be where your whole is. So we're going to have a whole, which is a removable discontinuity, where x minus 3 equals 0. Okay? So whatever factor cancels or divides out, that is the factor that's going to give you your removable discontinuity, which is at positive 3. So that takes us over here to the left once again, to the front of our worksheet. And this is number 10. What's the limit as x approaches positive 1? Well, the left side goes to 2, and the right side goes to infinity. So the left side is not equal to the right side, so the limit does not exist. If the left side and the right side don't match up, then the limit does not exist. Okay, which I believe takes us to this one, where we want to once again find a removable discontinuity. So factor. Look at that top thing. How are we going to factor that top thing? We're going to factor it by grouping. So we group the first two, and we group the second two. Okay? So if it's a cubic with 4 terms, we're going to factor it by grouping. What do these first 2 terms have as a common multiplier? X squared. Leaving me an x minus 4 factor. Okay, this is how we factor by grouping. And then the second 2, what do 3x and minus 12 have as a common multiplier?
3.
A 3, leaving me with an x minus 4 common factor. Okay, now let's jump to the bottom. What do x squared minus 6x plus 8? What numbers multiply to give us 8 and add to give negative 6? X minus 4 and x minus 2. So which factors cancel out? The x minus 4. Right? The x minus 4's canceled out. So we're going to have a whole where x minus 4 equals 0, which is at x equals positive 4. Okay, that takes us over to here. Oh, what is this lovely question? Is this piecewise function continuous? Okay, so we're going to use our definition. Number 1, is it defined? Yes, you see an equal sign right here, which means our y value is defined. Okay, so we're going to use our 3-part definition. Check. F of 0 is defined. What does f of 0 equal? No, not 0. F of 0 equals 1, because it's 0 squared plus 1. Okay? And that's the second part, is the limit as x approaches 0 from the left. Right? We haven't done that one yet, but this is the limit as x approaches 0 from the right. Right? That answer is 1, because that's what our y value is when x equals 0. Okay, so we just have to approach it from the left. What about cosine? So what is the cosine at 0? That's what we're being asked. What is the value of the cosine at 0? And if we remember our unit circle, 0 radians is here at the coordinate 1 comma 0, and cosine is the x value. So the cosine of 0 is 1. Okay, wonderful. That means the limit as x approaches 0 of our function is in fact 1, and our function is continuous. Okay, because notice the y value equals the limit. Okay, that's what we're looking for. Does the y value at 0 equal the limit at 0? And sure enough it does, which means our function is continuous. So that's our three-part definition. We have the value defined. We do the limits at that value by looking at the left limit and the right limit. So both of your two equations, and seeing if your y value is equal to your limit. If all of those things are there, then our function is continuous. So that takes us to the other side, where we have this algebraic simplification. Okay, so make sure you know how to square something. Squaring means multiplying it by itself. Okay, so 4 times 4, 4 times h times 4, h times h, which is 16 plus 8h plus h squared. Okay, and then we're going to multiply both of these things by minus 3. So that's a minus 12 minus 3h. And then I have this negative 4 hanging out there at the back. All divided by h. And that's the limit as h goes to 0. Okay, let's see. Anything to combine? I guess I have some h's. I have an 8h here and a 3h there. Right, I can combine those into a positive 5h. I have 16 minus 12 minus 4, which is 0. Okay, so those ones get rid of each other. So I have h squared plus 5h. That's all I have left. All divided by h. Right, 16 minus 16 is 0. 8 minus 3 is 5, and I have an h squared. So what can I do now? Divide 1h from each of my terms. I divide 1h from each of my terms. They all have an h in common, so 1h divides all of them. Now, when I plug in 0, I get an answer of 5. Okay, so that algebraic manipulation wasn't that bad. We just had to square something and then do some distribution. Okay, we're going to skip 14. It's pretty easy, but 14 brings us over here to this one. So notice we're going to have an asymptote at positive and negative 1. Okay, so we're being asked what is going on the left side of our vertical asymptote. Okay, so we're going to plug in a number like 0.9, right? That's a number that's a little bit to the left of positive 1. So 0.9 over 0.9 squared minus 1. Okay, so 0.9, well, that's a positive value. 0.9 squared is, I believe, 0.81, right? Because 9 squared is 81. So 0.9 squared is 0.81. 0.81 minus 1 is a negative number. So if I have a negative number, that means my graph goes down to negative infinity. Okay, so the little minus up here means as it approaches from the left, so we're plugging in a number a little bit to the left of our vertical asymptote. Okay, and that takes us to this side where we find the limit as x approaches 1 from the right. So from the right, our graph is going in what direction? Up to positive infinity, right? This little plus sign and minus sign means we're only looking at a one-sided limit. Not the both sides, just one side. And that takes us back to the beginning. Wonderful job. Okay, limits and continuity, plus the intermediate value theorem. That's what's on your next test.